Hello everyone, my name is Jordan Hernandez and today we'll be looking over Demo 3 Learning Target 3B. So what is Learning Target 3B about? Learning Target 3B is defined, I can simplify 3 and 4 variable switching functions through a Canard map or K-map. And what are cardinal maps? Our cardinal maps are going to be another truth table. However, it's a little bit easier to read and it helps you out simplifying an expression. So, and since we're going to be doing 3-bit and 4-bit cardinal maps, we can see that for the 3-bit one, we can put either variable of A or C at the end, basically A being 0, 1, and then BC being 0, 0, 0, 1, 11, and 1, 0. And in the middle, we can see we have different types of expressions of what they represent, so you can plug them in. 4-bit ones, also the same thing over here for 3-bit, except these are going to be more double. And as we can see in the inside, here are basically what we can see. All right. So here's an example of a 3-bit version, but this time we're going to start with the Boolean expression. As we can see, we have the Boolean expression of Q is equal to A prime, B prime, C prime, plus A prime, BC, plus A, B prime, C, plus A, B, C. Excuse me. And our first step is to basically set up our cardinal table, which will look like this. For this one, I am going to do AB over C. As we can see, AB is going to have 0, 0, 0, 1, 11, 1, 1, and 1, 0, while C has 0 and 1. So when we look at this map, we can basically plug in to some variables. So we have A prime, B prime, C prime. We will basically plug it into our 0 functions right over here. And for A prime, B prime, C prime, over here, A, B, C prime, over here, ABC, right there. So, be like this. And for now, we're going to ignore these spaces because there's no variables that can fit in here. The next thing what we wanted to do now is to group our functions. And usually groupings could have certain ways, but it's always going to be anything that's closest to the value of 1. And it could be represented as like a 4, or it can be like 4 squares, 2 squares, or 1. And as we can see in our example, we have about 3 groupings. We have the grouping in 0, 0, 0, the grouping in 1, 0, 1, as well as a 1, 1, 1, and then 1, 0, and 1, 1, 1. Or 1, 0, 1, and 1, 1, 1 as well. So what our next slide is that we basically get to know which expression is in each grouping. Our first expression is going to be up here. It's going to be A prime, B prime plus times C prime, and the other one's going to be B times C. The bottom one's going to be A times C. So when we put it as our simplified function, it's going to be looking like this. Q is equal to BC plus AC plus A prime B prime plus times C prime. And this will be our simplified version of this expression. Now for our next example, it's going to be a 4-bit cardinal map. But this time we're going to start with the cardinal map. Because there's going to be some equations where you're going to have this. There's going to be some problems where we could start with the cardinal map, and there's some where we could just start with just scratch, as we can see from the previous equation. But here we have down here A, B, and C, D. We have 1, 1, 0, 0 being 1, 1, 1, 0, 1 is going to be 1, 1, 1, 1, 1 is going to be 1, 1, 1, 1, 0 is going to be 1, and here's a new value in 1, 0, 0, 0 is an x value. And usually for our x's, they could be represented as 1 or 0 in our expression. So we could just leave it be as for x. So for 1, 0, 0, 1, it's going to be 1. 1, 0, 11, it's going to be 1. 1, 0, 1, 0. which is going to be 1. But since we do have this x, we can still count it as part of a grouping since it could be represented as 1. Or, which shows in our next slide, yeah, we have our groupings with 111 x 111. And since this is an expression where we have the value of just 1 of A, and then looks like B just changes as well as our C and D values, we could just express this as Q is equal to A. This is the end of Demo 3 Learning Target 3B. I hope you guys all enjoy, and I'll see you all next time.